kind of quickly. Okay, so to simplify, if you had 12 36s, you're going to find a number that divides into 12 and 36, and you're always going to find the highest number. So we're going to do 12, and it turns into 1 over 3. That makes sense? All right, to find equivalent fractions, they are saying 5/6. So to do 5/6 to find an equivalent fraction, you can do two things. You can multiply up or you can divide down, but you can only divide down if the numerator and the denominator both have a common number. So does 5 and 6 share a common number? No. So we can only multiply up, and you can multiply up by any number you want. It just has to be the same number multiplied by the numerator and by the denominator. So 5/6 is our number. And if I multiplied that by 2, it would be 10/12. And if I multiplied it by 3, it would be 15/18. And if I multiplied it by 4, it would be 20/24. So all of those are equivalent fractions. Does that make sense?
Yeah.
Okay. The next thing is to order fractions.
I don't know what's happening. It's like...
What, honey? I think I lost you. To order fractions from least to greatest, then if you have 1/3, 5/6, and 3/8, you would find out which one is the smallest and which one is the middle and which one is the largest. So to figure that out, you can find a common denominator that goes into both 3, 6, and 8. So it would be 24. So we can't just change a 3 to a 24. What would I have to multiply it by? I would multiply it by 8. So this would become 8/24. This one would become 20/24. And this one would become 9/24. Now that we have the same denominator, we can see that 1/3 is the least. 9/24 is the second number. So this would be the least, this would be the second, and the greatest number would be 5/6, which is 20/24. So then you would put them in order: 1/3, 3/8, and 5/6. Does that make sense?
Yeah.
Okay. And then to change a mixed number to a improper fraction, we do denominator times whole number plus numerator. So 8 times 2 is 16, plus 3 is 19, and then we put it all over the denominator. To change an improper fraction, like 42/4, you would divide 42 by 4. And how many times does it go in? It goes in 10 times. And the leftover the remainder would go as the numerator, and then the denominator would stay the same. So we would have 10 2/4, and then we would simplify that by dividing both the numerator and the denominator by 2. Are you with me so far, my darling?
Yeah.
Okay. For section 2.6, it's changing a fraction into a decimal. So if I had 4/25, I would put the denominator here and I would put the numerator here. So what is my denominator? 25. And my numerator is 4. Can you see this okay, or are you having a little bit of a hard time?
It can like load. It loads, but sometimes it glitches.
Okay, I'm recording this too, so I'll send you the recording. Okay, so how many times does 25 go into 4? It does not. So we add a decimal and a 0. How many times does 25 go into 40? 1 time. 1 times 25 is 25. And then we subtract. 40 minus 25 is 15. We add a 0, bring it down. How many times does 25 go into 150? So I'm going to guess 5 times. We have to go 1 more. So then I'm going to say, let's see if it's 6 times. Oh, 15. So it is 6 times. And it goes in evenly. So this is the same as 0.16. If they want you to put comparing numbers together, like 1/4, negative 0.2, negative 2/9, and 1.1, we would turn all of them either in fractions or all of them in decimals. And I would just turn them all into decimals. So if you can use your calculator, you're just going to do 1 divided by 4 is 0.25. Then this one is negative 0.2. For this one, we're going to do 2 divided by 9. It's 0.22 and it's negative. And then 1.1. So now we put them in order, and we know that our negative numbers are always going to be smaller than our positive numbers. So then you would take it from there and put them in order from least to greatest. Does that make sense to you, darling?
Yeah.
Okay. And then 2.8 is scientific notation. Do you remember that from last year?
Scientific notation?
Yeah, scientific notation. Okay, so it looks like this. So we have...
Yeah, I do.
Okay, so if it is a 10, the exponent tells you how many zeros are after the 1. So 10 to the 1 first power is 10. 10 to the second power is 1 with 2 zeros, so 100. And what it basically means is 10 times 10. 10 to the third power is a 1 with 3 zeros. And what it means is 10 times 10 times 10.
Okay.
If it's not a 10, which scientific notation is going to be a 10, it'll look something like this. So what this means is 2.3 times 10 to the second power. What is 10 to the second power, Jalen? Jalen? Okay, I think I lost you. It's 100. So then I would do 2.3 times 100. So 2.3 times 100 is 230. And another way to figure it out is however many zeros you have, you would move your decimal 2 places. So I have 2 zeros, so I'd move it 2 places, and my decimal would now become 230, and then the decimal after the 0. Okay, so that is the concept of scientific notation, and then putting it into scientific notation. We have a number in scientific notation is written as the product of two factors, one greater than or equal to 1 and less than 10, and the other a power of 10. So, for example, if I add 7.5 times 12, they want us to count how many zeros there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we would go, okay, let me show you a different way. So if we have 7.5 times 10 to the 12th power, you're basically going to rewrite your decimal, and you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then you're going to fill all of them in with zeros. If they want you to do the opposite, where they give you this and they want you to put it in scientific notation, you're going to do basically the opposite. You're going to count how many zeros there are, and it's always going to be 7.5 or something that is in between 1 and 10. So for this one, we have to make it a number in between 1 and 10. So we're going to make it 3.84, and we're going to move the decimal over. How many would it take? 1, 2, 3, 4, 5. So our number for our exponent is going to be 10 to the 5th power. So 3.84 times 10 to the 5th power. Let's try another one. So for this one, it's 2.3 times 100 million. And we know that because we would do 2.3 and then we'd have times 1, 2, 3, 4, 5, 6, 7, 8. So this tells us the number of zeros. This tells us this part right here. And then we would count that out. So it'd be you just got a connection. Are you back, Jalen? Okay, so then you would move the decimal 8 places to get this number right here. Okay. Can you hear me, Jalen? I see that you're on, so I'm gonna just keep teaching. You can watch the video if you can't see me.
Almost up.
All right, so if I had two numbers like this, 3.4 times 10 to the 3rd power, you could either figure it out by saying this is 10 times 10 times 10, which is 1,000. So 3.4 times 1,000. So on your calculator, you would do 3.4 times 1,000, and it would be 3,400. That is method 1. And method 2, which is easier, is to move your decimal over, or your decimal place over the number of spots of the exponent. So the exponent is 3. We would move it 1, 2, 3. So I think that's easier. All right, let's try a few more. 5.9 times 10 to the second power. Method 1 would be to do 5.9 times 100 on your calculator. Or method 2, we move our decimal over the number of spaces of our exponent. So we would do 1, 2, and fill it in with a 0. It would be 590. All right, 5 times 10 to the 11th power. We would do 5, and there's an imaginary decimal after every number. So we're going to put that in, and then we're going to go 11 jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to fill each of these humps in with a 0. And that is our number. We can put our commas in. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So this is the ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions. So this number is 500 billion. Okay, I'm not sure if you can see me or not, but I will keep going.
I can hear you and see you.
Okay, awesome.
I'm walking in my room right now, and then I'll join on my laptop.
Oh, perfect. Okay. So those are kind of the main points of chapter 2. And of course we have word problems and things like that. So I am just going to think of some questions, and then we can do them together, and I will stop the video.